Welcome. This is the introduction video for SAP HANA BI and BO training course. First, we look at the overview and purpose of these components, HANA BI and BO, how it relates to each other, and also how it relates to the functional module SAP ECC system as well as non-SAP IT solutions. Later on, we will get into the details about the training course. Any IT application, either it creates data or it gathers data. It stores the data in the relational database. This data is called OLTP data, online transaction processing data. The underlying data model for OLTP data is the entity relationship model, where you have the parent-child kind of relationship. And this model is very suitable for transaction type of processing, where we need to query a certain set of data and present it back to the users. But when it comes to analysis of the data, this is not the best model. The best model as per the industry standard is the star schema or the dimensional model. We will get into it later as we discuss the star schema and extended star schema as it relates to SAP. But for now, let's focus on this OLTP entity relationship data model. We need to do analysis of the data in order to get better insight about the business process, so that we can do some changes for optimizations, improve the process, etc. Basically, we need to convert the data into some kind of information, and that information then translates into business knowledge for better insights and process changes. Here you can see the properties of OLTP data listed on the left hand side, as opposed to the properties required for the analytical data. So in short, there is a gap which exists between the OLTP data and also our overall goals for the business in terms of improving efficiency, etc. And this gap is called a business intelligence gap, which is exactly what the SAP products HANA BI and BO tries to address. Now let's get into the details about HANA BI and BO. The OLTP data is represented in the form of cylinders, whereas the data which are used for analytics is represented in the form of cubes. This process is basically a two-step process, where in the first step we convert the OLTP data into OLAP data using SAP BI or BW. Okay. So the whole purpose of BI, to put it in very simple terms, is to convert the data, OLTP data, and then convert it in the form of OLAP data, cubes and DSOs, dataset objects, so that we can do the analysis of the data more easily. Once the data is in OLAP format, then we make use of the BO, business objects reporting tools, to consume the data. So it's easier to consume and do the analysis and reporting if the data is in the OLAP format as opposed to the OLTP format. This is one representation of the process. Again, this explains the two-step process. The first step is we have multiple data source in different formats like SQL, Oracle, DB2, etc. These are different types of databases on which the OLTP data resides, and using the BI tool, or there are other comparable tools in the market also. So the first step is to convert the multiple data source in multiple formats into OLAP cubes or DSO objects. So this is done using BI tool, BI, or it can be done in HANA also. The next step is to consume the data, consume the overlap data, either for reporting or for a further analysis of it. This is another such architecture. Different companies follow different architecture. This is one such thing. So we have multiple data sources, and then all the data is moved into operational data store. The data in the operational data store is typically whatever data required for the analysis, and here we use a ETL tool to move the data from the source to the operational data source. SAP ETL tool is BODS, it's Business Object Data Services, and once the data is in the operational data store, it is moved to data warehousing. That's where the conversion happens from OLTP to OLAP, and if required we can split it into individual data mart. Later on the data is consumed using the reporting tool like dashboards, Webby, etc., or it can be used for further analysis and data mining. So what are the different types of end user reports which is part of BO? We'll look at it very quickly here, but I will go into the details of each of these different reporting formats later on when I discuss the BO course content. But for now, let's quickly go through that. If you require a highly formatted report, then there is a crystal report component. We can also go for web intelligence if it is a ad hoc reporting where the user can create their own reports, or if you want a highly visualized report, then we can go for Celsius or dashboards. Dashboards are typically dynamic, where we can change the input values using some graphical interface, and the report graphics change accordingly. These are some of the typical reports, end user reports, which are generated or created using the BI data or HANA data. And it's not only restricted to the system or paper, it can be used for mobility also. We can push those reports to mobile applications like iPad and Android, etc. So again, these are typical highly visualized reporting which we can generate from BO tools. Okay, this is a simple but highly important system landscape. We need to understand the end-to-end layout of different components, how it comes into picture. Of course, in each of the training course, we will be going into the details of either BI, HANA or BO, but either you work in BO or BI, HANA, it's very important that you know the end-to-end landscape in real world situation. We need to know where the data comes from, what is the input to the system which we are working on. For example, if you are working in BI, you need to know what is the input to it, what is the output, how the data is consumed. Likewise, if you are in BO, we need to know where the different source systems from where we can get the data from, and what are the outputs from the BO. So it's very important to know the end-to-end architecture or landscape of any BI solution. Typically, we have a source data which can be either SAP ECC systems like modules, PP, production planning, material management, sales and distribution, or it could be a non-SAP solution where the database can be DB2, Oracle, etc. And once the data is in the database, it is kind of replicated or transported to the BI solution, where it is converted into overlap cubes or DSO. If it is SAP BI, it's converted to extended star schema data model and converted into overlap cubes or DSO. DSO stands for data set objects. and once the data is ready in BI, it can be consumed by the business objects for reporting purpose. So this is one such path. The other possibility is business object reports can access the data directly from the source system, or it can consume the data through HANA. The data from the source system is dumped into HANA, which is in-memory database, and then it is used in the reporting layer, PO. I will come to the difference between SAP BI and HANA, the advantage of using HANA over SAP BI later on. But for now, these are all the possibilities. SAP BI and HANA can coexist. If a client already has the BI setup in place, they have two options. Either they can port or migrate the BI data into HANA, or they can have it as a individual system if they want to have it that way. So the end purpose, whether you have BI or HANA or the data source, is to generate some kind of reports using BO or for analytical purposes like data mining, etc., and then for the end user. Let's summarize. The ECC system is like different modules like PP, SD, MM. There are multiple modules, functional modules in SAP R3. So those things forms part of SAP ECC. And BI, at a very high level, we can say its purpose is to convert the OLTP data into OLAP data, which facilitates easy analysis and reporting. Later on, BO is the reporting layer, reporting tools. Again, we have multiple types of reporting like crystal reports, Webby, dashboards, etc. And depending on what the user wants, we can use that. BODS is the ETL tool. Basically, it moves the data from point A to point B. In this case, we can move it from ECC system to BI. Okay, let's move on to HANA. What is HANA? When you have the BI, why do we need HANA? HANA, the definition is high performance analytical appliance. Why do we need HANA? Whether the data is in OLTP system or OLAP system, the underlying storage device is a mechanical device. It's a disk. It's very input output intensive, which creates bottleneck. Actually, we need a lot of time to read the data, write the data, and also to seek the data in the disk, which is very input output intensive, and it consumes a lot of time. And the memory are very expensive, and as I said, OLTP data, it's all optimized for transactions, and BI data can mitigate the transaction time to some extent, but still that's not the best solution. That is why SAP has proposed HANA. HANA is a in-memory database system. These are all some of the drawbacks of the traditional BI system. For example, we need to do the aggregation before we store the data, so that it's easier for us to report the data during the reporting process. So what is HANA? HANA, as I said, is a in-memory database. It's not only the memory, huge memory, it's also the software. It's a combination of software and hardware, which forms or which enables the different features of SAP HANA. What are these software features? What are these hardware features? For example, the hardware feature, you can have RAM starting from 128 GB up to 8 terabyte of RAM, and you have multiple processors, multiple blades, and you can have CPU, multiple multi-cores, up to 16 cores per CPU. These are some of the hardware improvements which SAP has come up with. So the net result is it speeds up the process, and also it has come up with multiple software features. It uses different, like a Trex for text search, and then we'll go into the multiple software features which are enabled in the SAP HANA. So the bottom line is on the it speeds up the system. On the software side, one main difference between the traditional database and this is here the column store and the object store is enabled. Typically in relational database only the row store is there. The column store enables high compression. We'll look at the reason how high compression is possible when it comes to column store, and also they use partitioning and things like that. One main feature of in-memory databases, aggregation tables are not required because the data is already available in the memory and it can very quickly do the aggregation. And also the loading time is greatly reduced because the data is directly dumped into the memory. We need to just do the inserts for the delta data. So in short, HANA speeds up the process. Not only that, the delta management becomes hassle free because the system takes care of it. And the third thing is that data modeling is not absolutely required. It is better if we can do some modeling in the HANA, but it's not really required. We can actually dump the entire OLTP data into this and do the reporting of it. So this is going to save a lot of time. So in one such POC where 460 billion records were analyzed, the typical BI ran for 77 minutes, whereas the HANA completed the same analysis in only 13 seconds. So in short, we can say HANA improves the processing time, and also it saves time on data modeling, and also it becomes becomes easy for us to do the delta management. These are the three main advantages of using SAP HANA over BI. Now we will go into the course details of each one of these, HANA, BI and BO. Let's look at the training details for HANA. The first and foremost reason why one would prefer HANA over the traditional BI is the speed, the capacity of the processor. We have seen for one such POC that the speed for HANA is 3500 times faster as compared to the traditional BI for the same query. So the first and foremost is the great speed at which the processing happens for such a high volume of data. Second is HANA has got a very low delta management. Delta management is the process of identifying and applying the changes which are done to the application system. So HANA has got a mechanism where this delta management process can be vastly reduced. It's a low maintenance delta management process. For example, there is a concept called aggregation in BI where the calculations are like predetermined and aggregates are applied. For example, if there is a change in the application side, the value of the aggregation will also change. In the traditional BI, the process involves identifying all the aggregation which uses that value, de-aggregating it, then applying the new value, aggregating it again, and then making changes to the database, data warehousing database. If we have aggregation, let's say at 25,000 spots using this value, then we need to do the de-aggregation and do this process for all the aggregate values. Whereas in HANA, the aggregation concept is pushed to the database layer. So the application layer is just required to send one small instruction as to what the changes are, and the rest of the process happens on the database side. So this vastly reduces the time it takes to apply the changes for the aggregation. This is just one example, but overall the delta management is much easier when it comes to HANA. One other major reason for going for HANA is low data modeling time. We talked about in the initial screens, where we need to convert the transaction data, the OLTP data, into OLAP data, the analytical data. So this is a process which are usually done by a trained professional. Data modeling itself is a big task for this data warehousing solution. But as far as HANA is concerned, the data modeling is not really required. It would help if we do the data modeling and then apply the data modeling. It's going to still speed up, but it's not absolutely required. We can just dump the OLTP data onto the HANA, and the HANA works perfectly fine. It can perfectly handle the data modeling. We will see these features in the slides. Okay, this shows the increase in the speed. So it says for a 460 billion record, HANA is 3600 times faster. The HANA consists of the HANA database consists of the calculation engine, which is the heart of this. It is so powerful and it can handle very complex calculation on the fly, and also it has a in-memory row and column stores. Plus, in order to get the data from SAP as well as non-SAP data sources, we have a real-time data replication SLT technique, and also the data services BODS is near real time, where we can fetch the data from non-SAP data source and bring it into the data in memory. And also we have the HANA Studio, which is the development interface, and we also have the information composer, where we can see the data, planning data. On the other side of the HANA, we have the client tools, where we have the business objects and other reporting tools. This is the basic setup of HANA. So as the volume of data, as the variety of data grows, the traditional BI is not an optimal solution to handle that huge volume of data. There are several drawbacks or limitations when it comes to variety, volume and velocity of data, such as suboptimal execution speed, lack of transparency and reactive business model, things like that. And HANA addresses all these problems. When I say HANA, HANA is both hardware and software solution. On the hardware side, SAP has introduced multiple cores per CPU. We can have 10 cores per CPU and also multiple CPU per board. In this case here you have 8 CPUs per board, and then we can have multiple boards in that server. So a typical server can have up to 2 TB of RAM. So overall we can have up to 320 cores or more, and we can have 4 TB of RAM or more. So this is a very huge memory size and like a huge number of cores. So this can facilitate handling of large volume of data very easily in HANA. This gives the power on the hardware side to the HANA in-memory database. So this tells how the technology in-memory capacity has increased over time. On the software side, HANA comes with row storage and as well as column storage. This slide gives the concept of column based storage. Column based storage has two main advantages. One advantage is it is highly compressible, in the sense if the actual application data is let's say 100 GB, If it is a column store, it can even gets compressed up to 10 GB. It's we can have a compression ratio up to 1:10 or 10 times the compression ratio. The concept of compression goes like this. Let's say you have a data like customer data, country, product and amount data, and the column store stores only the unique values. So it can associate the value to each of these rows. So in this case, if you have a product, there are only 2 unique values. So instead of 4 rows, it just stores 1 row or 2 rows. So it can be compressed to that extent. So here if you see there are only 3 unique values, it can be compressed. So if it is a row based storage, we would be storing all the 4 values. Here since it's only column based and we have only 3 unique values, so we can save space to that extent. Here there are only 2 unique values, so it can be saved. So and that is one advantage. The other advantage of column store is it's easy for the memory to be read, the data from the memory to be read. This is how the data is organized within the memory. If it is a row store or column store, as you see, the data is stored by row, and in the column store it is stored by column, and all the required values are on the consecutive cells. So it's easy for the processor to pick up those values and use it for processing. So column store has got its advantage. The whole concept of in-memory database calculation engine, or the whole concept is we are pushing the calculation from the application layer into database layer, so that the transport of data from database layer to application layer is vastly reduced. This is one performance improvement techniques where the data is split or partitioned based on the year. For example, if you have multiple tables, so the data from each of the table based on the year is pre-calculated, or it's already split up, and then it is stored on the individual blades. So if a query requires data for a particular year, it knows where exactly to look for. Instead of scanning the whole data volume, it's going to look at only a particular location on the disk, so that we can get the value. And one other feature, software feature of HANA, is the parallel processing. Each core can handle a separate column independently and simultaneously. For example, if you have 4 columns and there are let's say we have 3 columns in this case, column core 1 and 2 can handle column A and B independently. Column C can be handled by core 3 and 4. So this is going to drastically speed up the processing time, because each core is handling a particular set of data independently and simultaneously. So in summary, HANA brings its greatness by combination of hardware and software. We have seen the hardware feature. On the software side, we saw how the row and column store works, and how the compression can be enabled for column store. We just saw the partitioning, and one big advantage is for traditional BI, there is a process for aggregating the values so that it can be used. The aggregations are pre-calculated values which are used during the query time. In case of HANA, the aggregations are not required, since the value is already available in the memory, which can be calculated on the fly during the processing time. So this shows the situation where we use the column store, or the situation where the row store would be a better option. These are the approved vendors who manufacture these servers, like IBM, HP, Cisco, Fujitsu and Dell. So if you see this setup, this is the classic setup, which is how the ERP solution or the BW solution is implemented in most of the companies today, where you have multiple IT solutions, either ERP solution or non-SAP solution, each one having its own database. And then we have a local data mart and their corresponding database, which caters to the local BI or the reporting needs. And we have a overall enterprise level BW, where we have its own database sitting on top of BWA, having its own reporting or analytical layer. But slowly this setup is moving towards the HANA based database, where the individual data mart database is replaced by a single HANA database. The enterprise level HANA as well as the local data mart database can be the same HANA database, and we can report. We have the reporting layer out of BW, or it can be from the local HANA database for the local BI. So the vision of SAP is to implement HANA database for any type of application, be it SAP ERP or a non-SAP or any application, whether even for a data enterprise data warehousing as well as for a non-SAP application. SAP's vision is to implement a common database, HANA database, so that the data is available in memory for all the reporting as well as for the application needs. So it's going to be a great future for the HANA. So as far as the job prospects is concerned, so many companies are implementing HANA. Either they are replacing their existing BI, or they are creating BI on top of HANA, or they are having HANA as well as BI coexisting together in their IT stack. So many companies, and currently it's one of the hot skills required. As part of this course, we would also help you for the certification. We will provide you the guidelines and procedures to apply, and then to appear for the certification. We will help you on that. So coming back to our presentation, so we saw the main reason why one would go for HANA, and we also saw the internal workings of HANA. For this course, we will be covering all these topics. We will be covering in detail each of these topics, which are the basics, fundamental concepts of HANA in-memory database. In addition to that, we will be working on the exercise where we will be identifying a use case. Let's say we have a COPA data from ECC system. We'll identify the tables, COPA tables from the ECC system, and you bring those tables into the HANA database, and then create the data modeling on those data, and we will consume that data for our reporting purpose. So it's going to be a very comprehensive end-to-end training program. It's not only limited to HANA. We will also be comparing HANA with respect to BI and as well as other data warehousing tool. So we will be covering from ECC solution, how the data from the ECC solution flows into HANA, and from HANA to the BO tools, all the different reporting tools. I hope you enjoyed this presentation. If you require more information, or if you are interested in joining this course, please email us or contact us. Thank you.